Hey, what's up YouTube? So here we are, still on Model 1, the quadratic, nonlinear. See if we can pump out a couple more lessons. Alrighty, so still working on this simple regression, even though I don't think it's very simple. So let's just jump right into it. Yesterday we did 2 days in a row. And if these seem kind of redundant, I might try and do 2 days in a row too. So what can we say with lessons created by AI? But at least I'm learning something. Okay, so here we go now. Day 10, the slope coefficient A, or alpha. All right, the goal, relate the quadratic coefficient to thermal mass. The coefficient alpha 1 determines how quickly time grows with the delta temperature squared. So that's the zone temperature offset from occupied zone set point. Higher values correspond to heavier or poorly insulated buildings that warm slowly. Lower values represent lightweights, responsive zones. The PNNL Model 1 A1 is computed from the previous day's data. So by tuning the alpha parameter A1, you can make the model fit the observed warm-up behavior or cool down if we're in a cooling application in hot summers. Apply the concept using the formula or algorithm provided. Refer to the mini examples for demonstration. Why this matters: understanding this concept will allow to build more accurate, more efficient energy optimal start models. Okay, so here we go. Let's take a look at this. So day 10 looks kind of similar to yesterday's. So bring this down a little bit. So our delta T, if you remember, our delta T would be our, let's say, I like to always visualize this delta T as like zone temp equals 66. Let's say our zone temp is 66 at 3 o'clock in the morning, and our zone set point is 72 degrees F. Make these into floats. We could say this value minus this value. I think it's always confusing when they say delta T, but it's actually the occupied zone set point minus the zone set point. So let's try and run this. I don't think they're doing any tuning yet, but I think they're just predicting. So this is the formula that they're just predicting minutes. So here we go with here's the alpha parameter A at 0.5, we predicted 20 minutes. Alpha parameter 1, we predicted 38 minutes. And the alpha parameter 2, which is right here in the list, we predicted 74 minutes. So with the same delta T. So yeah, big difference. So what did that say? As if A increases, what happens to the predicted time? You know, we saw that big effect. So why might the exterior zone have a larger A parameter than an interior zone? That's kind of obvious, because if we're exterior zones will definitely cool or heat up the most overnight when the building's off and the HVAC is off. They just have the most load for heating and cooling on it, so that's pretty obvious. How could you experiment with determining alpha 1 for a particular building? How could you experimentally determine alpha 1 for a particular building? That's kind of a weird question, but I think that you could, like if you looked on an actual chart, let's say we were looking at trend data and we could actually kind of guess that, our warm-up times based on something like this from just like a linear observation, you might be able to kind of half come up with these, I guess. I'm not entirely sure. It seems like kind of an odd question. Create a Python file that performs the calculations from this level. So okay, so I think I might just, they gave us a Python file. So maybe I'll just kind of jump to the next lesson. So this one was alpha A. So this day 10 alpha A parameter. Let's just jump to day 11, see if we can knock this out of the way too. Okay, so this is where it might get a little trickier. It's been a little while since I've done any math. So this is like simple regression, line fitting. So regression finds the line that minimizes the squared vertical distance between your data points and the model. For linear relationship y equals alpha beta x, the ordinary least square solution has closed form expressions for the intercept and slope. So this is the intercept, that's the slope. I still have to remember what closed forms expressions are. Wikipedia gives you the formulas for alpha and beta in terms of sums of x and y. You can also implement these formulas directly in Python in Model 1 or 0. I think what this comes down to is closed forms expressions. You kind of for loop through your data, and you add up the values. I could be wrong on that. I'd be really curious if there's anyone out there that would be able to comment on that. And if I'm describing it wrong, apply the concepts above using the formula and algorithm provided. The mini example, understand this gives you more accurate and optimal start algorithms, of course. Okay, so here's a little Python program to simulate. Hate it when they use this zip function. Even had it say to create lessons without using the zip function, and the AI still created a zip function. I think it's just hard to, for a beginner to, it's like a utility, like in here they're for looping through this and kind of adding all the values together, but I think it's kind of hard to understand this for someone that might be starting out in Python, and I really don't even use these very much. So, and then this is actually the formula that they're doing to compute the slope B and intercept A. So I might just copy this, paste this into here. I want to see if I can rewrite this. So that seems pretty basic. They're summing this. Then they're computing the beta and alpha based off of kind of iterating over this saved data. And remember, this would be, I'm trying to think, like, it almost makes me curious to ask a couple questions to AI. So like this was, one of these was delta T's. I think one of these was delta T's, and then this one of these was warm up times, I think. I had a question open to ChatGPT a little bit earlier, so maybe we'll just upload. we can just, let's start chatting, why not? Lessons, maybe I could go just upload a couple of these lessons. Just say, I'm on day 10 of my lesson and the data structure X's and Y's in the data structure X's and Y's was one of these columns supposed to be delta T's and other would represent, let's see, we have delta T in warm-ups in minutes. It is this. Okay, so while that marinates, I actually thought of something else too. So like in the vibe coder repo, in the optimal start, we could actually drill down into the quadratic Java code. There's a lot of Java code in here, so, and it's more of like the computer science algorithm part of it, but there's one part of here where they are doing something, they're doing this process right here, but in Java world. I just wanted to see if I could find it. It would be kind of fun to copy it. So here, I think this is our compute regression. So in the Java program object, every time that we predict optimal start with the quadratic model in the program object, we do this same thing. So maybe I'll just do this, and we can maybe try and see if we can not cheat at all, but manually do like a little bit of convert this to Python, which I don't think should be too hard, but okay, let's just see. I'm sure ChatGPT finished now. So you're thinking about this the right way, then this is actually really common and good for short answer first, then I'll map it to your real HVAC, meaning X, Y. X's represent the independent variable and Y's represent the dependent variable. Oh, okay, so cause and effect. X's are the delta T, so that's our delta T, and warm-up time in minutes. So yes. All right, so let's okay, so that's correct, basically. So this was delta T's, how far zone temp is off from occupied zone set point. And then this is actually our minutes. So let's see if we can convert some Java code from Python to, from Java to Python. So what I want to do, let me see, how can we do this? Think. Okay, so I am just going to get rid of this. I think we'll have to like revise this data structure a little bit. So we would be doing, I'm just going to, let me think. So this would be, we'd have to do this. We'd have to do, should probably do like tuples instead of lists, but trying not to cheat with AI. Do it the old-fashioned way if you're trying to learn. So this would be 1 and 10. Next one would be 3 and 18 minutes. So doing this number and this number. Next one is 5 and 27. So 5, 27, and the last one will be 7 and 40. So here we go, 7, 40. Then I think we could see if I can do this. There. So this is kind of like a little data structure that we've been using. So I don't know if we'll need that. See if we can just iterate through this now. So we would say, we could just say data equals this. So if we do okay, so this first column was, let's see, that was delta t, and then that was time. So we could say delta t time in data print. Let's print them. And then saw error out. Yep, okay, so that was right. I think like in the real world, you probably wouldn't use a list of lists. You would probably do something where you use like a tuple instead. But this is just for learning purposes. Okay, so I think like we would do, so this was to try and not use this this stupid thing. I think it's just confusing the way that they do. To me, I can understand it better if I'm actually seeing how the math works individually than trying to use like whatever the heck they're doing in here. Okay, so what they're doing here, so this is what we want to do in our for loop. So we can do this. If we get stuck, we can just ask ChatGPT to. So we can even use these same variable names. And then I think we could do, so we need to know the number of days. So if we print length data, okay, so hold up. Maybe Python is not happy with the way this is written. I think we would just do it that way. Cannot unpack. I think there's a fancy way of doing this, but I'm just going to just define these one by one. Whatever, that'll work. Okay, so that works. So I just wanted to make sure that that was measuring 4 days of data. So it's just taking the length of that little data structure. So I could do days equal that. Okay, so then we'll loop through our data structure in through here and then update these on the fly. We'll be doing this basically. So I'm probably gonna have to have ChatGPT double check this, that I'm doing this right. So in this code, the Java code base, what are they doing as X and Y here? So, okay, so they're saying X is delta T and Y is time. So X would be this variable. And then Y would be time. Sum X squared. Oh, they just have it. We just have it spelled different. So this is just this guy right here. And this is the same little math formula that I think is kind of confusing, but so N is just our days. And this is how we... So, okay, so I think this is, I think this should work. So as we, we're doing this the old-fashioned way instead of this way, which I don't learn anything from this. But this kind of helps me doing it this way. When we for loop through our little data structure of our saved data, it just kind of helps me see how this is, how it comes together, I guess, on each iteration of the loop. So let's see what we got here. Cool. So that is our fitted line equation, if I understand this correctly. So, and then, yeah, this is pretty cool. So actually then, if we had, so each time that we predict our optimal start, and then if we wait till the next day. And let's say it's tomorrow at 5 a.m. and then let's say tomorrow's really cold. So tomorrow's space temp is 55 Fahrenheit in, let's do 60. 60 degrees Fahrenheit if the building gets down to that overnight. That's pretty cold because usually we'd want to warm it up to maybe 72 degrees. Tomorrow's space temp is 60, so our occ heat set point is 72. So then we would say our new delta T, I think I'm using it here, so I can just say this, tomorrow equals occ heat set point minus this. So then we would just kind of run that through our equation here, which would be y, which would be minutes, I think. So minutes for warm up would be alpha. Let me see. So alpha, it's this. Be alpha plus beta times delta T tomorrow. And we could just say print minutes. 63 minutes of warm-up time calculated. So this is pretty interesting stuff. I kind of like this. It's really, these optimal start blocks don't have to be complete black boxes. So it's really cool, the people that come up with this stuff. I wouldn't be able to come up with this stuff or even this, but it's really kind of fun understanding it, studying it, I guess. So this was kind of fun. And it's in the Java code and program object. You know, this is all stuffed inside there, these same concepts. Calculating the slope, and they're calling it denominator. So I'll have to find out what they're doing there. Oh yeah, that's just, we do the same thing here, I think. Wonder why they're calling it denominator in the code base. Denominator of n. I have to think about this. Anyways, so maybe we can just study that in more detail. So I might just we can even have ChatGPT double check. Say, how did we do? You did really well, yay. Alright, so here we go. So alright, so that's all I have for today. So thank you for joining me. This stuff is getting pretty interesting, so we'll talk to you tomorrow. So tomorrow will be day 12, and we probably already did day 12's lesson already with moving ahead, so we'll see you tomorrow on day 12.